Thank you. Good afternoon. So it's quite a mix in the audience, so I hope to clarify a bit what AI is and where it's heading. So I have spent a couple of years in machine learning research and then almost a decade in startups that had data science or machine learning as a strategic component in their business. And even for myself, clearly monitoring this field every day, reading about new things happening, it's typically really confusing what's going on. So it's challenging to keep clarity on where we are and where we are going. So this talk is my attempt to try to clarify it for myself and also to share it with you, and hopefully all of you will benefit and have some useful takeaways. So if you are reading these standard tech articles, you are seeing all kinds of opinions on artificial intelligence. So probably the most famous person in this field is Andrew Ng. Probably some of you may know him from Coursera. So he has been the co-founder of Coursera. He has been running the machine learning course there. There has been millions of people doing that course. So probably he is the professor who educated the most people using machine learning today. And he's saying that AI is as important as electricity 100 years ago, and it will have a transformational impact on what we do in the next few decades. On the other hand, Stephen Hawking probably needs no introduction, and I'm just paraphrasing him. He said, AI will kill us all, which is not a very promising future for us. So there are all kinds of extreme opinions happening when people talk about AI. You can check Dr. Fei-Fei Li. She has been the head of AI at Google, and she has been instrumental in the whole deep learning revolution and the image recognition field. She's also saying this is a new revolution, as important as the Industrial Revolution. And then you meet Gary Marcus, who built a machine learning company, sold it to Uber, and has been the head of AI at Uber. And he's saying that all of these things have been promised for 6 decades, and it's not here yet. Sometimes he's going as far as saying we are about to experience the next AI winter. And the good things about Game of Thrones that I don't need to explain why winter is bad. So Gary Marcus is saying that we will be doomed, and all this AI hype will just collapse fairly soon. And then you go back to Andrew, who is saying we are in the eternal spring of AI. So please, can we check our calendars? The explanation may be that Andrew is in Silicon Valley, which is the eternal spring, and Gary is in New York, and New York has the fair share of snowstorms over the year. But it's crazy. These people are so experienced in their fields. I truly respect all of them, and still they seem to disagree so much on where this is headed. So I'm here today to try to clarify this a bit and dig one level deeper and see what are the different fields of AI and why these people may have different opinions on where this whole big field is going. But before I do that, let me introduce a metaphor that I would like to use throughout this talk. And this is called the circle of human knowledge. This is from Matt Might. He's a computer scientist who turned into precision medicine. And actually, he will be visiting CrunchConf in October and will be presenting on this very stage. And he has lots of interesting articles and blog posts. And this one is from 10 years ago, and this is how it goes. Imagine a circle that contains all of human knowledge. By the time you finish elementary school, you know a little. When you finish high school, you know a little more. And when you finish your bachelor's degree, you start to specialize in one direction. With the master's degree, you deepen that specialty, and by reading research papers, that takes you to the edge of human knowledge. When you're there, you start to focus. You push the boundary for a few years, until one day, the boundary gives way. And that dent you just made is called a PhD. But your world looks very different now. So don't forget the bigger picture and keep pushing. So 10 years ago, as a PhD student, this has been very inspirational for me, that it was easier to for all my family to relate to what I'm doing. Hey, I'm just pushing the boundary of human knowledge and not just doing some crazy matrix manipulations to predict time series. That wasn't really an appropriate phrasing of what I do for a Sunday lunch. But over time, I realized that maybe this is not the right boundary for me to push, so let me build on this metaphor and extend it a bit and use it for the field of AI. So I called it the circles of artificial intelligence. So again, let's imagine a circle that contains everything that we can do, everything that is possible with AI as of today. So obviously, researchers are pushing that boundary and making more and more things possible every day. Then there's an inner circle, what is practical today from the perspective, is it cost efficient? Can we actually use it in practice? Does it have a sufficient latency? Lots of engineering questions and business questions like cost and benefit. And there is certainly a boundary there that typically startups are pushing. So there's something new, something that is recently possible, and startups are trying to make it practical, productizing it, making it useful for different fields. And there is an even inner circle, which is ubiquitous, making it available for everybody, basically, for millions or even billions of people. And typically, large corporations are good in rolling out services at that scale, so certainly no researchers or no startups are experienced with that, but large companies can push that boundary and deliver services to so many people. So as a personal story, for many years, or a couple of years, I've been trying to push what is possible. So I've been doing machine learning research, and I still like to think that I made some contribution to the field, but over time I realized maybe that's not the right boundary for me to push, and then turn to startups and try to make these new innovations, new technologies practical for everyday use for as many companies as possible. And I think what is important here is that there are very few people that can push multiple boundaries at the same time. So typically, somebody has certain skills and certain mindset to push one of these boundaries. If you're a researcher, you should really dive deep and try to push that boundary, go where nobody has gone before. But if you don't have that mindset, don't have that dedication that you can really spend years with one single thing, then maybe you should be pushing a different boundary. And there's no shame in pushing the boundary of ubiquitous and being at a large company and rolling out services to billions of people. I think that's a really exciting thing and a huge impact that you can have in the field of AI or in any field, really. So let me zoom in, and I will use it as a map to kind of lay out the different use cases of AI and the different areas of AI. So in the very center, so the low left corner, are the things which are very ubiquitous. Everybody is using them, AI applications that are everywhere. And on the far top right, there are things that we don't even know if those are possible. So I will start from ubiquitous and see what are the machine learning and AI services that we already use today. And I want to refer to Hilary Mason. She just had a recent talk at Strata conference. She's one of the most famous data scientists and currently the general manager of machine learning at Cloudera. And literally her opening line was, let's make machine learning really boring. And what she meant is, as soon as these services come into our daily lives, we just tend to forget about them. It's not AI anymore. It's just a service that has some smartness in it. But we always refer to AI and machine learning that is kind of far out and we cannot still use them. But when these things become part of everyday life, we forget about them and they become boring. So one great example of that is down here is email spam filters. So if you're old enough to remember, 20 years ago, this was a huge problem. Like some people even went that far that said there's a risk that the internet would not succeed because of spam filters not being good enough, or email spam being such a big problem. And so today, there are 4 billion people using email. So if you can make a small improvement on email spam filters, you are impacting the lives of 4 billion people. So it's a huge impact activity if you do that. Still, very few people are excited about this, right? So we just forget about this standard use case that is available for all of us. And just try it in the next coffee break. So somebody approaches you, so hey, what do you do? And you say, hey, I'm working on self-driving cars. Oh, wow, cool. And there are lots of questions popping up. Compared to that, if you say, hey, I'm working on optimizing email spam filters. Oh, good luck. And that was it. So we tend to chase the new and shiny objects in every field, and that's true for AI as well. But let's not forget about these pretty reliable machine learning use cases that are supporting our lives every day already. So let's take another example, which is recommender systems. So if you visit any web store, or if you visit Netflix, basically it's estimated that more than 50% of the viewing of those movies is driven by the recommender system. So that's huge. That's part of our everyday lives. And if you think about it, also our social media timelines. Like a couple of years ago, they were still ordered by time, but for a few years, it's optimized for interest. So what are you most likely to like? What are you most likely to respond to? So it's basically a recommendation. This is what you may prefer. This is what you may like. And even if we stretch the definition of recommender systems, you can consider like personalized advertising, targeted advertising as kind of a recommender system. What is the ad that you're most likely to be interested in? It's part of our everyday lives. There has been many people working and optimizing these things, and still we forget that these are driven by machine learning, and every one of us are using these services. Let's take another example, speech recognition. So I would assume that most of your mobile phones are capable of doing that. We can still debate how good that is, but it is available for most people. And also, sometimes you don't even realize these speech recognition services working. So if you call a call center because you have some problem with some service, I guarantee that there is something going on in the background, and they are recording your call, and they are, in many cases, in more modern companies, they are doing speech recognition, and for the operator, real-time offering what may be the solution for your problem. These are systems that we don't even see and don't even recognize and supporting our daily lives. But these are the boring stuff, right? So you didn't come here to hear about spam filters. So let me cover a couple of more exciting or interesting shiny objects. Oh yeah, just a note that these are not completely randomly placed. So whatever has more open questions, more open problems like, are more towards the top. So recommender systems, obviously every one of us has our own social media bubbles, and fake news, and all of those things are pretty open questions to be solved, while spam filters are pretty well understood and not much room for optimization. And the size of the bubble is kind of the amount of hype, the amount of media coverage that is happening in these fields. So let's see the next, games. So there has been a lot of discussion about games, how AI can deal with games. And there has been a couple of breakthroughs in the past few years that I would want to cover. So first of all, AI became superhuman in many of the board games. So Go most recently, a couple of years ago, but chess has been defeated a long time ago. So these games are special because they have perfect information. So the computer system knows everything about the state of the game. And they have a finite number of moves that people can make. So I'm not saying it's an easy problem, but it's definitely a limited problem with no rare long-tail events. And also, it's very compute intensive. So whenever you hear these announcements, they are not really disclosing that. But to build the AlphaGo system, it was millions of dollars of hardware needed for that. So it's not like you can do it at home. So these are basically, humans are defeated. And some people can draw the conclusion then, oh, AI is here to kill us all, as Stephen Hawking said. But there are quite a few things that needs to happen for AI to really become better and in more areas. So for instance, if you consider computer games, these games have imperfect information. So you don't always know where the enemy is and how they behave and what their strategy is. Still, it's a finite number of moves, so there are no rare events that never happened before. And again, very compute intense. So how OpenAI and all of these companies are addressing these problems is via lots of simulation and these systems playing against themselves. So that's how they are trained. That's why it's so compute intensive, because they are basically training these big neural nets to decide the next move based on lots of games that they play against themselves and also play against humans. So for instance, Dota 2, which was last year, they barely couldn't win over the humans. And one of the reasons was that previously they have been playing with professional Dota 2 players and training the system based on what they do. But that as soon as they started to play against the top 5 players, they had very unique strategies that the system was not prepared for. So after that experiment, they are saying that this year, for sure, they are defeating the humans, and Dota 2 will be a game owned by AI and always defeating humans. So simulation is crucial to generate enough data, but still in this finite world, in this world where no rare events can happen, still there, simulation was not enough. So millions of dollars spent on simulating this environment was not enough to defeat the top human players. After they learned about their strategies, obviously now they are simulating those strategies as well, and we'll be able to defeat them fairly soon. So this is not quite real life yet, but it's a huge breakthrough, a huge accomplishment, so I'm not trying to downplay what they did. But on the other hand, we still have lots of open questions to extend these results beyond games. So let's see where these are on the map. So board games are really kind of solved. They are becoming practical. I actually have a business idea for you to share. So if there are some prototypes of chess games that defeat you 100%. So that's not very practical, because why would you play a game that you always lose? But maybe if you build in microtransactions where you can play the system to make a random move, that might be a pretty compelling chess app that many people would try. But so games, AI in games does not seem to have a very practical use cases. But still, many people say that this might be a stepping stone to something bigger. So game is a limited reflection of the real world, a limited set of the real world with some simplifications. And if we solve those, maybe it becomes easier to solve the bigger problems. Then there are other group of researchers who are saying, oh yes, but all those simplifications that you make in those games, actually those are the hard problems, and solving games is not leading to solving general intelligence or something broader. But that's still a big debate among AI researchers on how useful solving games are and what can be the outcome long term. But let's move into something more human, language. So AI historically has not been very good with dealing with text and dealing with language and understanding what was written. But machine translation has definitely had useful applications. So just the fact that I can go to Google Translate and translate any language to English, that's fairly useful. And also recently, there has been a couple of interesting applications of text generation. So based on a couple of sentences, generate me a bunch of text about that topic. And these applications are fairly good, so you cannot always recognize the difference between a human written text and a computer written text. And this can have interesting applications in marketing and in various areas. So I would say that machine translation that's available already, not perfect, but it's fairly useful, and text generation is likely to have a breakthrough in the next few years when we will start it more and more in probably smaller niche areas. But talking about language and text is not very good on slides, so let's move on images. So Probably some of you have seen the headlines recently that AI can generate human faces. So if you're wondering, none of these people are real. So these faces has been generated by an AI system which has been trained on millions of faces, and the system learned what a face looks like and could generate a lot of similar faces, but these are not real people. But if we just take a step back and check what happened before, so basically in the past decade, there has been a huge progress in dealing with images and how computer can recognize images. So there is this object recognition competition called ImageNet. Basically the error rate of these systems has fell from 30% to 2% in a couple of years. That's an amazing breakthrough that was facilitated by deep learning primarily. And the really shocking part is the human error rate is around 5%. So when you're looking at these charts, it makes you wonder, how on earth can it be that humans make a mistake 1 out of 20 images and cannot recognize what is on the image? So I was wondering about this as well. So first of all, it's important to understand what top 5 error rate means. It means that you can make 5 guesses. So if your top 5 guesses are correct, you're good. If you did not have the right answer in the top 5, you made a mistake. So if you see that, it's even more confusing. How can it happen that 1 out of 20 times humans make a mistake and cannot even figure out, based on 5 guesses, what is on the image? So if you go deeper and check what the data set is, it's almost 500,000 images with 1,000 classes, but 90 of those classes are dog breeds. So I don't know about you, but if I would be forced to list more than a dozen dog breeds, I would be in trouble. So no surprise I cannot recognize them. So I would say it's kind of unfair data set for humans, but still we need to see what a great accomplishment has been in the past few years, that computers can really do a great job on recognizing objects on images. So it's getting practical. Definitely, like Google Photos and many of these photo apps will group your photos based on what's on them. So that's a pretty practical use case and quite useful. Image generation is another story. So I think it's a very interesting solution that is looking for a problem to solve. So I have a hard time imagining an image generation use case that is ethical and useful for society. Probably most of the applications will be on creating fake images and things like that. But I hope there will be something more useful than that coming out of it. So the next big topic I would like to cover is autonomy, self-driving. There's a lot of discussion about, OK, when do we have self-driving cars? And here I want to highlight the big difference between solving games and solving things like autonomy. So if you make a bad move in a Go game, you may lose. That's fine. That's quite a low risk. You will do better next time. If you make a mistake in self-driving, somebody dies. So it's a very high-risk decision system, so it needs to be designed in a very different way. So it's not allowed to make big mistakes. Also, the other part is, in games, we had a finite world, so no really rare things could happen. Nothing could happen that never happened before, right? On the other hand, in real world, there's all the time, it's the case all the time, that new things are happening, new vehicles appear on the road. If you train your machine learning model on data from the US and Europe, then you may miss the point when you're driving in Thailand, there's an elephant next to the road. That's a pretty unusual thing, and you definitely didn't have training data on it, so it's a rare event that didn't happen in your training set. So how do you deal with those situations is not easy. I've seen a demo from a self-driving company, AI Motive, where they have a simulator, and they simulated driving in Sweden and still decided to do rare events, so a kangaroo jumping by and crossing the road, because they realized that, okay, it's really unlikely, but if you're driving next to a zoo, this may happen. So the system needs to be prepared for very rare events. Otherwise, it will not be able to deal with those and run into trouble. So if the environment can be simulated, or you put a lot of effort into simulation, then that's probably one of the key things for self-driving to make it successful. But many people don't know that there are different levels of self-driving. So currently, the cars on the market are, at least the better cars, are on level 2. So they have a couple of autonomous functions working together. So for instance, they can park themselves. You could argue that makes them more capable than some of the human drivers. But this year, it's expected that the first level 3 car will hit the road, where it will drive itself most of the time and only alert you when it is in big trouble. But level 4 and 5 may be pretty far out. And no matter what you read from Elon Musk or the latest TechCrunch article, there's still a long road ahead to get there. So level 2 is already on the market, level 3 is coming, and level 5, hopefully it's possible, but it's very far off. And then that leads us to the holy grail of artificial intelligence, which is general intelligence. That's basically, you do not need to train an AI system for a specific task, but it will just try to train itself in various things and have a generic understanding of the world and a generic capability to act in the world. So I'm not a researcher anymore, but I think even the researchers would agree that this is a long shot. This may be very far out in the future, if even possible. So there are lots of challenges, and I will highlight one of those challenges in a moment. So this is definitely the top right corner. That's where many researchers are fighting for to get there. But as you can see, some people are working on computer games and defeating the humans in StarCraft. That's quite a big jump still to get to general intelligence from that. I have one more topic, one more use case that's fairly one of my favorites recently. And let me illustrate that with a personal story. So meet my son, Pete. At the moment of this picture, he was 1 year old, and as you can say, he likes to eat. While eating, he realized an interesting phenomenon. When hot food was served on the table, adults and other children started to blow air. And he was like, wow, that's interesting. Let me try that as well. So when the next time he received some hot food, he swallowed this hot food and started to blow air. It took him a few days to realize that there may be a cause and effect relationship between these two activities, and learn that, okay, I need to blow air before I take the food, and I need to blow the air towards the food. He was 1 year old. So naturally, 1 year olds realize that. And here's the bad news. Current AI systems that we are using today, they have no idea about cause and effect. They have no idea how to learn what is causing what. They are just looking for correlations, and if those correlations happen, they predict what the outcome will be and may define some action. But they don't necessarily understand why things happen in the real world. And this has been fine for many years, because really our goal with AI systems was, let's just observe what happened before, and let's predict what will happen next. Or let's recognize something that happened before, like on an object on an image. But future AI systems, especially combined with robotics, they will intervene into the world. They will have actions. They will do actions. If they don't understand cause and effect, that will have terrible consequences. And if you don't believe my son, then you should listen to Yoshua Bengio. He's one of the fathers of deep learning, as they say. He recently received the Turing Award, which is basically the equivalent of the Nobel Prize for computing. And what he's saying is, he was one of the instrumental people for deep learning. And what he's saying is that he still likes that, but we need to go beyond that. That's not enough. That won't be able to solve reasoning, learning cause and effect, and to explore the world. So an agent needs to explore the world, learn the cause and effect relationships to have a better understanding and be able to interact with the world moving forward. If you're interested in this topic, I highly recommend Julia Pearl's book, The Book of Why. That's a pretty interesting read, and it's not too deep, so it can be read by various audiences. So this is kind of the complete picture. So casual modeling, it's crossing what is possible, but it's far from practical. So there are no easy ways to use these cause and effect, learning cause and effect as of today. But as deep learning was quite an instrumental tool to help all these use cases, I would argue that learning cause and effect could have the same impact and could really advance many of these fields altogether. So this is kind of the complete map of how I would present the various AI use cases. And I think in many cases, the confusion comes from like mass media that sits here and typically talking about ubiquitous things that affect all of us, talking about self-driving level 5 or talking about artificial general intelligence and criticizing those researchers for not being practical enough. So they have a very different goal. They are really pushing and advancing human knowledge. They shouldn't care about cost and practicality whatsoever. They should be just pushing that boundary and then let other people push the boundary of practical and ubiquitous. So whenever you are trying to do an AI project or discussing some AI use case with somebody, I encourage you to recognize where you are on this spectrum, so where you are on this map, and approach it with the right expectations. So if it's a use case that is expected to serve millions of people, like an automated braking system in a car, okay, that should be pretty damn reliable. So that's basically the number one priority. On the other hand, if you are talking to somebody who working on an AI system to defeat humans in StarCraft, well, there is room for error and room for mistakes in that use case. So I hope this talk was useful to get a broad overview and kind of a guide to navigate this mess called artificial intelligence. And I hope you had some useful takeaways from it. Thank you.
Thank you very much for the talk. I believe we have a couple of minutes for Q&A. Let's come to the middle. All right. So the first question by Mirko. What is your opinion about ethical questions and personal responsibilities when it comes to AI making decisions which can be good, but also seriously bad?
So this is a typical question that comes up when things are rolled out to a wide audience. So this is not the question for what is possible with AI. This is about practicality and pushing services to many people. I don't have an easy answer for this. So there are a lot of these questions, like the typical ones, if an autonomous vehicle needs to decide basically who to kill, the driver or a child walking by. There are all kinds of these crazy questions that are impossible to answer. There are a lot of people working on this field. I don't have a clear response on what is the best approach, but there's a lot of work to be done. So I think technology is far, far ahead of what society can absorb at this point.
All right, thank you. Has AI ever dealt with the issue of understanding context of something, which is central to human intelligence, of course?
Yeah, so especially in language, context is everything. So there's some progress, but fundamentally we haven't solved that clearly. So like machine translation needs some context, so you need to know, so if you know the context, you can do a better job in translating the text. If it's a technical text or if it's a legal text, obviously that makes a big difference. But in a general way, I think that's one of the big fundamental questions on solving context and understanding context. It's just simple algorithms, relatively simple algorithms are just not prepared for that.
Oh, the questions are moving around. What is your opinion about the Google presentation with the AI assistant making calls in your name, like the haircut appointment?
I think it's a fairly practical use case, a pretty narrow one. So the interesting part is that just because we have heard a computer, a synthesized voice, and heard it to book an appointment, everybody was freaking out like, oh, wow, general intelligence is here. No, it solved a very small problem. And there are all kinds of tasks that it cannot solve. So if you just try any Siri or any of these technologies, you will pretty soon realize that they are not that good. In the presentations, they look great, but there are clear limitations. So it's great, but it's a very narrow thing.
If I'm a front-end or back-end developer, how can I get into machine learning?
I think the online courses are fairly good. So you should probably read some reviews. There are lots of articles comparing some of these lectures by different people. So Coursera is fairly good. But you know, the best if you learn it on the job. So if you find something in your daily job, in the product you own and you develop that could be improved with machine learning, just make the pitch to the product manager or whomever and try to make it a pet project. I think that's the best way to learn about machine learning, to actually do it.
Cool. Let's take a couple more. Do you have any idea to mark moon craters or small stones on Do you have any idea to mark moon craters or small stones on asteroid with AI? Do we really have to do it manually?
Nobody wants to do it manually, right? That was my reaction as well. I was sitting there and no way I'm doing that. Well, typically you need a fairly large data set for a machine to learn the patterns and be able to replicate what you just did. I haven't worked on that problem, so I don't know how far we are from that, but I bet that after some annotation work, it should be possible that no human would ever need to do that. But clearly, it's not solved yet. So please annotate. Maybe in a few weeks we are there, and no need for that anymore afterwards.
Cool. And let's take one more, because I really like this question. What's the best way to create bias-free training data? That's a good one. There are all kinds of biases. You just need to be aware what those are and how they could be hidden in the data set. So I think that's probably learning about those biases, you know, listening to talks and reading up about examples when some of these biases screwed up machine learning models and made huge mistakes. And then just being aware and trying to eliminate them. But there is no such thing as a bias-free training data. That's unfortunately the bad news. There will always be some bias. Depending on where the data comes from, there will always be human bias or some other kind of bias inside. All right, let's give another round of applause for Zoltán. Thank you so much for the talk.